Topic 14.4 Theory, Power and Efficiency. In this video, we will learn about how is the power, work done, and efficiency are related to each other. So objectives are determine the power generated by a machine, engine, or motor and calculate the mechanical efficiency of a machine. The formula definition of power is called work done per unit time. So this is work done, this is time. So this is the correct formula. Now work done itself is dot product of force into displacement divided by time. So this is also the correct formula. And we have learned in chapter 12 that dr by dt is also called the velocity. So it's f dot product. This is not multiplication, this is dot product. F dot product v, where f and v both are vectors. So the correct answer is all of the above. Kinetic energy results from kinetic energy is 1/2 mv square and it results from velocity. So velocity is the correct answer. So applications of power and efficiency. Engines and motors are often rated in terms of their power output. The power output of the motor lifting this elevator is related to the vertical force F acting on the elevator, causing it to move upwards. So when elevator moves upward with some velocity v, and the force applied is F, dot product of this two can give us the required power. So given a desired lift velocity for the elevator, how can we determine the power requirement of the motor? So we can calculate this using the dot product. Second application, the speed at which a truck can climb a hill depends in part on the power output of the engine and the angle of inclination. So as the angle of inclination increases, the speed at which the truck can climb that hill decreases. For a given angle, how can we determine the speed of this truck knowing the power transmitted by the engine to the wheels? Can we find the speed if we know the power? Yes, we can find that because power is F dot P. So if we know power, we can calculate speed if we know the weight of the truck and the friction force or the traction force that the engine applies on the ground. If we know the power output, if we know the engine power output and speed of the truck, can we determine the maximum angle of climb for this truck? Yes, that is also possible. So power is defined as the amount of work performed per unit time. If machine or engine performs a certain amount of work du within small time period dt, then power can be calculated as du by dt. Since the work done can be expressed as dot product of force and displacement, power can also be written as dot product of force and velocity, where both f and v are vectors, but the power itself is scalar. Remember that the output of dot product is a scalar quantity. Okay, thus power is scalar, defined as the dot product of force and velocity acting in the same direction. Dot product can also be calculated as magnitude of f multiplied by magnitude of v multiplied by cosine of angle between them, cosine theta. Unit for the power in SI system is watt, which is also called joule per second because work done is in joule, time is in seconds. So joule per second or work done is also Newton meter per second. So unit of power is Newton meter per second or joule per second or watt, which is more common for like day-to-day communication in SI system. There is another unit of power is called horsepower, which is, and for FPS system, the unit of power is foot-pound per second. This is FPS unit of the power. Apart from this and these units, there is another unit, horsepower, which is also more common. It's not SI unit or it's not FPS, it's a different unit, and we can convert horsepower into SI unit by multiplying with 746. So 1 horsepower is 746 watt, or 1 horsepower is 550 foot-pound per second in FPS system. So horsepower is independent of FPS and SI system, and using this conversion, we can convert it into either of the units. Efficiency of a machine is the ratio of power produced or output by the machine to the power supplied to the machine. So efficiency is output divided by input, and we use this epsilon symbol for efficiency. And efficiency is, since it's the ratio of output to input, it's always between like 0 to 1. If efficiency is 1, that means the power output is same as power input, which doesn't make sense in practical world because there are always losses associated with the machine, such as friction, heat, and noise. And because of that, there is loss of power. So power can be there is loss of power, and that's why the efficiency is between 0 and 1, but not 1 all anytime. If the energy input and removal occur at the same time, efficiency can also be expressed in terms of the output energy to the input energy. So this is another formula for efficiency. Either use the power or the energy equation. And yeah, this paragraph explains that energy is less than, like the efficiency is less than 1 because of these factors. So our problem solving procedure is to find the resultant external force acting on the body causing it to move. It may be necessary to draw a free body diagram. Determine the velocity of the point on the body at which the force is applied. Energy methods or the equation of motion and appropriate kinematic relations may be necessary. Calculate the power using this equation. And if efficiency, or maybe use this equation du by dt, and if efficiency is required, use the equation for the efficiency to calculate either to calculate the required input power if the efficiency is given. Or if both the powers are given, then you can calculate the efficiency by output power divided by input power. In the next video, we will solve problem using the power and efficiency concept. Thank you.